Welcome to our presentation. We created a book recommendation system for university libraries. Our goal is to make finding books easier and faster. We use smart techniques like collaborative filtering, metadata analysis, and matrix factorization. Let's see how our system works. The challenge. Libraries face three big challenges. The first one is limited time. Students have only a few minutes to find books. The second one, too many choices. Libraries have thousands of books, making it hard to choose. And the last one, no personalization. Current systems don't match books to each student's preference. Our solution. We built our solution in three steps. The first step, data collection. We gathered data on user borrowing habits and book detail like titles, authors, and subjects. The second step, algorithm development. We create an hybrid system using collaborative filtering, content-based filtering, and matrix factorization, SVD. And the last step, user interface. We design a simple platform to recommend books efficiently. Understanding the data. We use two main types of data. The first type is user interaction. We looked at borrowing history to find preferences. We prioritize recent activity with temporal weighting. And the second type, book metadata. We add information like title and authors to connect similar books. This solves the cold start problem for new users or books. And our methodology. We combine three techniques to build a strong hybrid system. Collaborative filtering, found users and books with similar borrowing patterns. Content-based filtering, used metadata to find books with similar topics or features. Hybrid system, mixed collaborative and content-based results with SVD for better recommendations. And this is the system optimization. We improved the system with three main optimizations. The first one is temporal weighting. Focus on recent user interactions to make recommendations more relevant. The second one, parameter tuning. Adjust parameters like alpha, beta, and SVD dimensions for better results. And the last one, performance testing. Checked the system using precision at 10 to ensure high quality recommendations. And user interface demo. Our interface has three important features. Personalized recommendations, you might like, section based on borrowing history, detailed books pages, information like title, author, and similar books, and user feedback. Users can rate recommendations to help improve the system. And the future enhancements, we have plans to make the system even better. User ratings let students give feedback to improve accuracy. Real-time updates, update your recommendation as soon as the new data comes in. And deep learning, use advanced AI techniques like neural networks for smarter recommendation. And the conclusion is what we achieved. The first one, better user experience. Students can find relevant books faster. More efficient libraries, improved use of resources and higher satisfaction, continuous improvement, ongoing updates with user feedback and new algorithms.
Here I'm going to present you the Streamlit app, and as you can see here, in the beginning we did define the book covers and used a Google API for that. And sorry, an open library API to have the covers of the books. Then we also have our CSV files also on the file of the environment so that the Streamlit app can properly work. Then we have a few navigation bars that I will present you right now what they are about, but here is also a little show of the code. I'm gonna now here relaunch our API. And so here we got here our recommender system with a home page where you can search, for example, for a specific book. I can here write the word demon, and there are a few books about it. If I go once again here, we can also see all of the metadata related to a certain book. For example, here for the dictionary Robert. Here we have all of the data. Then we got our recommendation. We can choose our user number 1, for example, and see what we recommend for him. And not only that, there is a history for him. So here we are also the books that he already read previously. We got also a little feedback submission part, just like on the model to build our Streamlit app. Then we got also an analytics part where we can see the key statistics and trends in library usage. Here are comic books. It's in French, but it's written comic books. There are also romances, thrillers, etc. And then we also added a little function called game. So this little game function is just a few questions from things about the books. We picked 3 questions. And for example, who wrote To Kill a Mockingbird? I'm going to choose, for example, F. Scott Fitzgerald, and it's wrong. So we try another, it's wrong. We try another, it's correct.
Welcome to this presentation of the UNIL Nvidia project. Designed as a part of an academic course in data science and machine learning, this project was developed by a dynamic team composed of Fabio, Guilherme, and Karim. The main objective of the project was to create a book recommendation system able of predicting user preferences based on their past interaction. To achieve this, we implement collaborative filtering techniques, including user-to-user and item-to-item collaborative filtering, while integrating hybrid approaches combining metadata and matrix factorization method. In the first phase, we conduct an exploratory data analysis to better understand the challenges within the dataset. The dataset includes 7,838 users, 15,109 books with interaction, and a total of 87,047 recorded interaction. The analysis revealed an uneven distribution of interaction. A small number of popular books account for a majority of interactions, while many books remain underrepresented. To address this issue, we introduced a temporal weighting factor to prioritize recent interaction while reducing the influence of older datasets. To build our system, we explore several methodological approaches. For collaborative filtering, you use user-to-user similarity based on the interaction matrix and item-to-item similarity to identify relationship between books. To enhance this model, we integrate metadata such as book, title, author, and subject using DF-IDF factorization to calculate content similarity. Finally, to address data sparsity and capture the latent feature, we implement matrix factorization via SVD. The results demonstrate that the strength of our hybrid model. By combining the score from the user-to-user, item-to-item, and metadata approach, we achieve at a precision at 10 of 0.5469 and a recall at 10 of 0.9035, placing our model in the top 10 of the Kaggle leaderboard with a final score of 0.1653. A concrete example for a user show that the recommendation produced by the user-to-user and item-to-item models were consistency and relevant, although user with few interactions occasionally receive less accurate suggestion. To address challenges like overfitting and computational complexity, we implement solutions such as cross-validation regularization in SVD, on the fine-tuning the hyperparameters alpha and beta. Additionally, the integration of metadata via Google Books API allowed us to add contextual information like description, categorize, and covers, further enriching the recommendation. In conclusion, this project demonstrates that the combining collaborative filtering method, metadata, and matrix factorization result in robust, effective recommendation, even with limited data. For the future, we plan several improvements, integrating deep learning model, customizing temporal decay, and exploring cross-domain recommendation to leverage data from other domains such as movie or film. We invite you to explore our GitHub repository for detailed technical insight analysis on the complete project source code. Thank you for your attention.